Okay, so we're good. We're back on class time again. We want to make sure we get through this as quickly as we can and pretty simply. Where we're going is we're going to 1.2 sets of real numbers. Now you've seen this before and you've seen this quite a bit, and we're not really going to stretch it too much. But first problem that they talk about is they talk about write all names that apply to each number on page 15. Right? So on page 15, they give you a model that talks about rational and irrational numbers. All right? And they give you a model of that, and it looks like this. You should see that in your book when you're looking at it, right? And in that book, everything is under real numbers. And this is just a simple set model, and it gives us rational numbers and irrational numbers. Remember, you got to be looking at the book to make this happen, because my handwriting between the equipment and all of that is going to make some things a little bit difficult, okay? So, we've got rational here, and everything that's in here is also rational. So integers, all right, are going to be like -3 and +1. Right? And whole numbers include anything that works out to being a whole number, a complete value. I don't like that they only showed this is a 0 in your book, but I don't like that they didn't show you the difference between positive and negative numbers. But we're talking about the number line here, so whole numbers are the 1, 2, 3, 4. And integers includes the -1, -2, -3. I hope you get that. You should recognize that whole numbers is part of all of this because it's 0. So everything that's here is a part of integers. And everything that's here and here is a part of rational numbers. Now on the irrational side, we have numbers that go on forever. If you grab a calculator and you put in square root of 17, you'll see that goes on and on and on and on. Or you might be able to determine that from the model you're looking at, or square root of 2, or the square root of -11. Okay, and of course pi goes on forever. We know that. We're going to talk about that several times this year because that's important as well. Okay, so that takes us to example 1, and it says the square root of 5. Square root of 5, and the square root of 5 is, once you hit the buttons on the calculator, you're going to see that goes on forever and ever. It's irrational, but it's still a real number according to the chart, and so on and so forth down those 3 models. Now, page 16 wants us to go someplace new. Page 16 talks about understanding sets and subsets of real numbers. And what I just said to you is all irrational numbers, if you look at the chart on page 15, here's our irrational numbers. Right? At the top of this, it says real numbers. So therefore, all irrational numbers are real numbers. That's a true statement. Now, if it says no rational numbers, here's where our rational numbers are. These are where our rational numbers are on the chart before. Our whole numbers, well, of course that's not true because we got a circle in here that says whole. So this must be true here, right? It's not that difficult if you think of that chart. So try and get that into your head. As we move on to example 3, example 3 is going to try to identify sets. For the real world, which is a little bit trickier, but it's not impossible. It's a little trickier. Situations. All right? Real world situations. So, what it says there, and you should be reading this stuff because it's going to help you to understand it a little bit better. Real numbers can be used to represent real world quantities. Highways have posted speed limit signs that are represented by natural numbers such as 55 miles per hour. Integers appear on thermometers, right? Negative and positive, right? -0 would be an integer. I need -1, -2, -3. Rational numbers are used in many daily activities, including cooking. Rational numbers means that we're going to look at a ratio. In this case, they look at 2/3 for rational numbers. That's a rational number. That means 2 divided by 3. Like for 2/3 cup of flour. So if we're looking at example 3, it talks about to identify the set of numbers, the number of people wearing glasses in the room. The set of whole numbers describes a situation. There's nobody in the room that's not a whole person. The number of people wearing glasses may be 0 or a counting number. Take a look at your classroom and see how many people wear glasses. Well, you can count me in there, right? So one way we can look at that selection for example 3A is in our classroom. Let's say we had 20 students. Let's not include Mr. Kolesnick. And 7, that's a little much, but 7 wear glasses. Can you think of a rational number that would describe this value? How about this one? It's a rational number, right? And it's 7 divided by 20. And we're going to talk about how that changes fairly quickly now. And then B talks about the circumference of a flying disc. All right, now. So the circumference of a flying disc, I'm assuming that's going to be a round disc, right? Has a diameter of 8, 9, 10, or 11 inches. Well, 11 or 14 inches. The biggest size is 14 inches. True that? So, what's the smallest size? 8 inches. So if it's 8 inches, how many of those are rational numbers? Well, we're talking about the circumference of that. So don't we have to think about, whenever we talk about circles and we're talking about circumference, and this is something you should have learned in 7th grade, what's the formula for circumference? Well, I always think of it as pi d, pi d, pi d, pi d, and I drive my students nuts every time we start talking about it. But c equals pi times d. If you remember, pi goes on forever and ever and ever. So this value is going to be irrational. Because we're going to multiply whatever it is by pi. And pi is an irrational value. It goes on forever, and it's never, ever, ever going to be the same numbers. So that should help you to get through the guided practice on 18. Make sure you're doing what you have to do to get to 18. And then 1.2 on 19 is going to be what we're going to be looking for your turn-in. Okay, so that's about 11 minutes worth of lesson. So that ought to be enough for all of 1.2. And this will be on our YouTube's folder, which is on the board over on that side. YouTube videos for lesson 1.2. Have a great day. Thanks, guys.